Today we're going to be talking about expected value. So the expected value of an experiment is the average result you would get if you repeated the experiment over a long period of time. So we'll start off with a simple example. Suppose I have a coin. If it lands on heads, I give you $1, and if it lands on tails, you get nothing. So what would be the average amount of money you would make? Well, a coin has a 1/2 chance of landing on heads and a 1/2 chance of landing on tails. So you would expect to make 50 cents. So we can extend this example to get the general definition for expected value. So suppose we have an event with n outcomes. Let's just call them x1, x2, all the way to xn, with probabilities of p1, p2, all the way to pn. So the expected value would be to just multiply the event happening by the probability it occurs. So we can use this to solve various other problems. So we're going to take it a step up from the coin. So this time we have a die with sides 1 to 6. So if you rolled it, what would be the average number you would get? Well, each number has a 1/6 chance of appearing, so the average number would just be 1 to 6, the sum of 1 to 6 divided by 6, which is 3.5. So now we're going to go look at a few problems that I have here. We're just going to go work through some of them. So we have number 1. Roll one die, recording the value that appears. Then roll a second die that many times, adding up the values as you go. Determine the expected total for the sum on the second die. So let's just say you roll a 1. That means you would just roll a second die once, which has an average value of 3.5. If you roll a 2 the first time, then you would roll the second die twice, and the expected value would be 4 because it's just the same thing as the first one, you're just rolling it twice. So we can generalize it as the expected value of rolling the die once squared, which is 12.25. Now we have the second one. Let me just draw this here. Select 4 distinct squares at random within a 4x4 grid. If you get 4 in a row, you get $100, and if you get 3 in a row, you get $5. So what are your expected winnings? Well, first we have to see how many possible ways are there to select 4 squares. And that would just be 16 choose 4, which is 1,820. So first we'll find the probability of getting 4 in a row. First we got the 4 rows, the 4 columns, and the 2 diagonals, which comes to a total of 10. So your winnings would be $1,000. And now we're going to find the probability that you get 3 in a row. So the lines I'm going to draw are the orientation of the 3 squares in a row. So you got horizontal, vertical, diagonal one way, and diagonal the other way. So there are 8 ways to pick it if it's horizontally, because like you could start 1, 2, 3 here, or 1, 2, 3 here. And by symmetry, the vertical ones is also 8. And then you got the 2 diagonals, which you can simply count 1, 2, 3, 4. So there's 4 here and there's 4 here. So in total, there are 24 ways to get 3 in a row, which comes to a total of $120. So now you would just add them up. So your expected winnings would be this number over here, which translates to $8/13. Now number 3. Dr. V has a 30% chance of scoring a 3-pointer on any particular shot. If he repeatedly shoots 3-pointers, how many shots will it take on average for him to score 18 points? So we can just find the expected number of points he'd get on one shot. So he has a 3/10 chance of making a 3-pointer, and let's just assume the other 7/10 you're just going to miss. So that comes to about 9/10 of a point per shot. So we're asked to find how many shots it would take to get 18 points. So you just divide the number of points by the expected value of points per shot, and that would come to a total of 20 shots. And now we're going to skip to number 7, which has more of an intuitive solution. No, there is no grand reason about this. It's just because I do not know how to solve 4, 5, or 6. If you do know, please tell me. So anyway, we're going to do number 7. So 2 points are chosen at random along the line segment of length 6. On average, how far apart are they? So let's think about this. If you break a line segment into 3 pieces, the average length of these 3 segments is just going to be that distance over 3, because at the end they're still going to add up to the original length. So that means the points where we break the lines is actually the 2 points that we're going to talk about in the problem. So on average, they're going to be 2 units apart. And that's about it.